Video looks at the calculations on belts and pulleys and gears. In this first example, we've got a driving pulley here and a driven, and we've got a radius of 0.1 meters on the driving pulley and 0.3 on the driven. It's producing a force of 500 newtons on the driven pulley. Now what we asked to find there is the torque caused by the force on the belly, on the belt of the pulley. So torque is force times distance. So we've got 500 newtons. We've got 0.3 meters there to the pivot point. So 500 times 0.3 gives me 150 newton meters. So that's the torque on that belt there. Calculate the force on the belt at the driving end. Assume that the torque on the driven pulley is the same as the torque on the driving pulley. So if we've got 150 newton meters here, then we should have 150 newton meters here. So torque is force times distance. So if we want to find the force, it's going to be the torque divided by that distance. So it's similar to the levers. If we know the two things here, 500 times 3, we times them together and divide by the other one. So 500 times 3 gave us the 150, divided by 0.1 gives us 1500 newtons. So there's a big force here. Now when we look at gears, instead of looking at the ratio of the diameters or the radiuses like in a pulley, we're going to use the teeth, the number of teeth. In this first instance, we're going to calculate the torque, like we just did previously for the pulleys. We've got 250 newtons of effort. We've got a distance of 0.2 to the pivot point. So the torque is force times distance. 250 times 0.2 gives me 50 newton meters. Power and efficiency. So a belt and pulley drive takes 1.25 seconds to complete one revolution and uses 250 joules of energy. So we're going to calculate the power used. Now we've done this before. Power is energy divided by time. So 250 joules divided by 1.25 seconds gives us 200 watts. Looking at efficiency, we've got the drive system to turn a generator. The input is 180 watts, but the power delivered by to the generator by the belt is 170 watts. So we're losing 10 watts. So what's the efficiency? Well, the efficiency is the power out divided by the power in times 100%. So 170 out divided by 180 in times 100 gives me 94.4% efficiency.